Okay, so today in 6.8, we're looking at something called the binomial theorem. I'm just going to skip ahead a couple of slides and I'll show you what we're doing. We're going through and we're expanding things. Right now, our only way to do that would be to go through and multiply all of these together by foiling and distributing and all of that stuff. Probably wouldn't be that big of a deal with the third power, but if you're doing to the fourth power or to the 10th power or something bigger, it could get to be a pain. So I just want to go through, and for the first few, I just want you to see a pattern here. So anything to the 0 power is 1. Here, anything to the first power is itself. If I were to FOIL this, let me do that real quick because I can do a plus b. A plus b would be a squared plus ab plus ab plus last b squared. So combine like terms here, and I would get a squared plus 2ab plus b squared. Now I could keep going here. I don't want to take forever on this, but I just want you to see your coefficients here. I'm going to go ahead and put the ones in. If I were to continue on, it continues in a pattern that's called Pascal's triangle. See how this is the part we had right here? Now just coefficients. We had a plus b, a squared plus ab plus b squared, but just the coefficients fit in with this. When you look at this first row here is like row 0. If anything to the 0 power is 1. This is to the first power, second power, third power, etc. Okay, so keep that in mind. Remember that this tells you coefficients. It doesn't tell you your exponents or your variables. It tells you coefficients. Now, if you want a Pascal's triangle, they have all sorts of them online. You can find one, but I want to show you the patterns on here. And like I said, this is called Pascal's triangle, so Google it. You'll come up with a million choices. This is the one I chose. I want you to see the pattern. See how you've got ones on the diagonals here. Now, from this point on, if you ever add up any two numbers, the number between them underneath is them added together. So see, 1 plus 2 is 3. 3 plus 3, 6. I'm just picking a couple of them. 6 plus 15, 21. So if you need to make your own Pascal's triangle, once you get your ones here, you can go through and do that. You'll have a 1 on the diagonal, add them together to get the number in between, 1 on the diagonal, and keep on going. Okay, so let's go through using Pascal's triangle and do a couple of these problems. Then I want to show you another option that you have. Okay, so this one might honestly be just as easy to do by multiplying it out, but I wanted to give you a small one to start out with. So I'm going to go through and first of all choose my to the third row over here. So 0, 1, 2, 3. So I'm going to have 1, 3, 3, 1. Those are my coefficients. I'm going to leave a little room in between them because I still need to deal with variables. And I'll just go ahead and put plus signs in between here. Okay, now what I'm going to do with my first term here is I'm going to start with it being to the third power. In the next term, squared, second. Next term, first. Last term, it's like it's to the 0 power. Anything to the 0 power is 1. So it's like it's not even there. Now, your negative 2 is the opposite. You can do one of two things. Either one's fine. You could either start at the back. I don't know why, but that's what I like to do. Probably just because I'm weird. I think I'm the only person who does it this way, not even there. Or you can say, It's to the 0 power, not even there, 1, 2, 3. Either one is fine. Then simplify down and see what you have. So negative 6x squared. So this is 4 times the 3 is 12. And here I'll have negative 8. So that's what I would get if I multiplied that thing, x minus 2 times x minus 2 times x minus 2. Okay, let's do one more, and then I want us to talk about another way to get these coefficients other than Pascal's triangle. Okay, so to the 4th power, so I'm going to go look at Pascal's triangle, and I didn't continue it on, but this would be the 4th, which would be 1, 4, 6, 4, 1. And I'll go ahead and put my plus signs in there. Alright, so the first term, I'm going to start to the 4th power and get smaller. Not even there. The second one, I'm either going to start at the back or I'm going to start with the not even there. So h to the 0, not even there. First, second, third, fourth. Now this one's actually nice because I don't have any simplifying down to do because it's only variables that I had in the part when I put the variables in. So I have g to the 4th plus 4g to the 3rd h plus 6g squared h squared plus 4g h to the 3rd plus h to the 4th. Alright, so second thing we're going to do is use something called the binomial theorem. Now, here's what we're going to do. We're going to use the binomial theorem in place of Pascal's triangle to get those coefficients. Now, we're still going to do the c to the 5th, c to the 4th, c to the 3rd, etc. We're still going to do the -2 to the 0, -2 to the 1st, all of that. We're just going to go through and do the part that we would get off Pascal's triangle using the binomial theorem. Okay, so here's what I'm going to go through and do. I'm going to use combinations from yesterday. My first term is going to be 5 combination 0. My second one is going to be 5 combination 1. You get the idea. 5 combination 2, 5 combination 3, 5 combination 4, and I should have written this a little bit smaller. Okay, so let's put those in the calculator. Okay, so let me clear out what I have. Okay, so 5 combination, so remember probability menu, number 3, 5 combination 0, which is 1. Okay, that's good because Pascal's triangle always starts with 1. Okay, now I'm going to show you a little math trick. If you hit second enter, it'll bring that to the next row, which will make it easy for you to go back and change this to a 1. Okay, 1, 5. And I'm going to keep doing that. Okay, so second enter, and I'll change that to a 2. And keep doing that. So I'm just going to do these quickly. Okay, so my last 3 are 10, 5, 1. Okay, let me put my plus signs in. Now, here's what I want you to notice before we go through and we finish this problem. Okay, this is the 5th power. Notice what I have here, 1, 5, 10, 10, 5, 1. If I go back over to Pascal's triangle, Look at that. See how these combinations got me the same number? The purpose of this is just giving you a second way to do this. So I may give you Pascal's triangle and say, do this using Pascal's triangle, no calculator, or I may give it to you on a calculator part and say no Pascal's triangle. So either one. So let me put in my numbers. So I have c to the 5th, 4th, 3rd, 2nd, 1st, not even there. -2 to the 0, not even there. 1st, 2nd, 3rd, 4th, and 5th. Okay, so this first one, remember, is not even there because it's to the 0 power, which is 1. And then I'm just going to go through and get everything simplified down. So here I have c to the 5th minus 10 c to the 4th minus 40 c to the 3rd minus 80 c squared. So I'm just simplifying these down, doing all the number crunching. So like here I have -8. -8 times 10 is -80 plus 80c minus 32. Okay, now the last thing I want us to do with these, and that means I am going to skip one right here, but the last thing I want us to do with these is talk about what you do if I don't ask you for the whole thing. So on this one, I'm not asking you to multiply the whole thing out, but I'm asking you, when you do, what is the 4th term? So here's what I do. I say, okay, because I'm a visual person, I say, this is the term I care about. So let me get my coefficient first. So I know it's going to be 5c, 5 because of this combination, with 0, 1, 2, 3. Okay, now I'll put that in my calculator, and I might actually already have it there because we did it a minute ago. 5 combination 3 was 10. So I'd already done that. I already had it in my calculator, so lucky me. Okay, now with the x's, I'll have x to the 5th, 4th, 3rd, 2nd, so x squared. And then with the 2, I'll have to the 0 power, not even there, 1, 2, 3. So 2 to the 3rd is 8, so 80x squared. So I may ask you for just one term. For me, I'm visual. I like to go ahead and put the spaces there. It makes it easy for me to count. Some people can do it in their head. That's fine too. Okay, one more of these. Okay, so we're doing 7th term. So I'm going to make my terms small. 1, 2, 3, 4, 5, 6, 7. That's the one I care about. And my little recording thing's in the way, so let me move it down. Okay, so 7th term. So first of all, I would have 6c, 0, 1, 2, 3, 4, 5, 6. So I'll see what that is. I think it's 1. So I'm just going to bring this one down from a minute ago. They both need to be 6. So that one needs to be 6. This one needs to be 6. So 1. Okay, in terms of my x, I will have x to the 6th, 5th, 4th, 3rd, 2nd, 1st, 0, or not even there. Now with my -2, I'll have -2y. I'll have -2y, not even there, to the 0, 1, 2, 3, 4, 5, 6. So -2y to the 6th. Now, -2 to the 6th is 64, positive 64, y to the 6th, so 64y to the 6th. All right, now these are a little bit tricky. I think that especially The larger ones, and we did skip one of the larger ones a second ago, the larger ones are especially tricky. So we're going to practice these in class some, but you do want to make sure you have the general idea down. All right, so that is expanding polynomials, fun stuff.